James Webb detected a chemical hook pattern in 3I/ATLAS that should not exist. A mysterious interstellar comet just tore through our solar system, surviving the sun's inferno, changing the color and defying expectations. Scientists are stunned, and James Webb Space Telescope saw something no one expected. Inside 3I/ATLAS, astronomers discovered that 3I/ATLAS has an extreme chemical imbalance, unlike any comet ever studied before. Water wasn't dominant, carbon dioxide was, metals were present, and the chemistry tells a story written across billions of years in deep interstellar space. This wasn't just a visitor from another system, it was a comet chemically transformed by its journey across the galaxy. And when it finally arrived, it shocked astronomers. Since July, scientists around the world have been tracking an interstellar object racing through the solar system at nearly 68 kilometers per second. But unlike previous interstellar visitors, 3I/ALTAS didn't pass quietly. It changed colors, fired strange jets, and at one point appeared to accelerate unnaturally. Blinded by the sun, in October, 3I/ATLAS slipped directly behind the sun from Earth's point of view. Ground-based telescopes were completely blinded. This was the worst possible timing. This was the part of its journey where solar heating should trigger the most extreme activity: violent outgassing, rapid brightening, maybe even destruction. Some scientists weren't sure if it would survive at all, but before disappearing, 3I/ATLAS left us a warning. The fire hose in space. NASA's Swift Observatory turned its ultraviolet instruments toward the comet. Swift detected something called hydroxyl, a fragment left behind when sunlight breaks water molecules apart. Scientists use hydroxyl like a fingerprint. If you see it, water was there first, and 3I/ATLAS was producing an unbelievable amount of it, about 40 kilograms every second. That's like a powerful fire hose blasting into space non-stop. And here's the mystery. This comet was nearly 3 times farther from the sun than Earth. At that distance, water ice should still be frozen solid. So why was this comet already erupting? The answer wasn't simple evaporation. 3I/ATLAS wasn't just melting. It was throwing chunks of ice into space, where they shattered and vaporized on their own. That multiplied the surface area, and it supercharged the comet's activity. Then it vanished behind the sun, watching from space. Earth may have been blind, but space wasn't. Solar spacecraft like SOHO, STEREOA, and GOES-19 use coronagraphs to block out the sun, creating artificial eclipses. Normally, they watch solar storms. In October, they watched a comet, and what they saw was dramatic. For months, 3I/ATLAS had brightened steadily. Then, suddenly, it spiked. Its brightness curve went nearly vertical. The comet was shedding mass at an extreme pace, far beyond what standard comet models predict. By the time it re-emerged from the sun's glare, it had become bright enough for amateur astronomers to image from Earth. But brightness wasn't the strangest change. Color was. The comet turns blue. Earlier in its journey, 3I/ATLAS appeared red, a sign of dusty, organic-rich material coating its surface. Then, as it plunged closer to the sun, Earth-based observers saw it turn green. But solar observatories saw something else entirely. Through specialized filters, the comet appeared blue. Blue light in a comet doesn't come from dust. It comes from gas, specifically glowing carbon monoxide and nitrogen-based molecules being excited by sunlight. This meant the sun had burned away the comet's outer shell, exposing the true, volatile, unstable engine of comet. And 3I/ATLAS visited Mars just before going to the sun, a world-seen interstellar object. During its speedy inward flight, the comet flew within 28 million kilometers of Mars. That gave orbiters and even surface rovers a once-in-history opportunity. NASA's Mars Reconnaissance Orbiter tried to capture a close-up of the nucleus, but even from that distance, the comet was wrapped in a cloud of gas and dust over 1,000 kilometers wide. The solid core was completely hidden, buried inside a vast cloud of gas and dust. Other spacecraft detected a vast hydrogen envelope surrounding the comet because hydrogen appears when sunlight breaks water molecules apart. Even though hydrogen itself itself can't be seen with human eyes, so this was strong evidence that comet was losing enormous amount of water. Then came the greatest picture of all. The Perseverance rover on the surface of Mars turned its camera towards the sky. It captured a blurred smudge floating through the sky of Mars. For the first time in history, an interstellar object had been photographed from the surface of another planet. Perihelion and disappearance. Then came perihelion, the comet's closest and most dangerous encounter with the sun. After that, the comet just disappeared behind sun, out of view from Earth. Did it survive? When 3I/ATLAS finally emerged from behind the sun, panic spread. Some claimed the comet had exploded. Others said it had fragmented into multiple pieces, but new observations told a different story. The comet was still there, still intact. What looked like an explosion was actually the comet shedding its outer layers, violently but naturally. Still, two features remained puzzling: a jet pointing toward the sun, and a slight deviation from a purely gravitational path. Some suggested artificial propulsion, but nature already had an explanation. No aliens required sunward jets happen when gas erupts from weak points on the heated side of a rotating comet. Solar wind then pushes that material back, creating a spike that only appears to point toward the sun. This has been seen before on Halley, Neowise, and Comet 67P. The comet's slight deviation from its path wasn't mysterious. It was the natural rocket effect. Gas blasting off the comet pushes it slightly in the opposite direction. Perfectly normal, perfectly natural. Then came the final confirmation. The comet survived its journey around sun. Its nucleus remained intact. Every deviation, every jet, every plume of gas, all were natural consequences of physics. No aliens or artificial propulsion required. The radio signal that closed the debate. South Africa's Meerkat radio telescope detected hydroxyl through the comet's dusty envelope. Radio waves pass easily through dust, so this detection was rock solid. This confirmed beyond doubt. 3I/ATLAS contains a lot of water. It is not a metal shell. It is not a spacecraft. It is not alien technology. It is a comet, though not a typical one. This comet has been cooked. Infrared data from James Webb and SphereX revealed something extraordinary: an extreme abundance of carbon dioxide. In normal comets, water dominates. In 3I/ATLAS, carbon dioxide is nearly 60 times more abundant than expected. How? Because this comet spent billions of years drifting between stars. Out there, there's no protection. High-energy cosmic rays slowly rewrite chemistry, breaking bonds and forming new compounds. Over time, the comet developed a radiation-processed crust chemically altered by the galaxy itself. In other words, this comet isn't pristine. It's been cooked. Metals, heat, and eruption spectra also revealed iron and nickel in the comet's coma. When melting ice contacts these metals, chemical reactions release heat. That heat melts more ice. Pressure builds, and eventually the surface ruptures, blasting jets of gas and dust into space. This process, called cryovolcanism, explains everything: the brightness surge, the jets, the metal-rich coma, the final flyby. Now 3I/ATLAS is leaving the inner solar system, but one last encounter awaits. In March 2026, it will pass close to Jupiter, inside the planet's gravitational sphere of influence. If conditions are right, the Juno spacecraft may capture a final view, an interstellar traveler seen from the outer solar system. After that, it will be gone. Why this matters? 3I/ATLAS has changed how we think about interstellar objects. Space doesn't preserve them, it transforms them. Every future visitor will carry the scars of cosmic radiation, chemical evolution, and time. 3I/ALTAS may not be an alien spaceship, but it is a time capsule from another star system, carrying billions of years of cosmic history in every jet, every burst of gas, and every trace of ice. Its journey is a reminder that the universe is far more dynamic and surprising than we ever imagined. If you enjoyed the video, smash that like button and subscribe for more mind-blowing space discoveries. Turn on notification and join us on every cosmic adventure.